Hi everybody, it's Mr. Short. Today what I'm going to do is to walk through the problem-solving strategies for this particular question. Then you'll solve this problem and also flip the sheet over and figure out what the problem-solving strategies would be on the backside and solve that problem also. Alright, so emphasizing the problem-solving strategies right here. It says if a sample containing 18.1 grams of ammonia, which is NH3. Now remember, anytime you read a given number, unit, and chemical, you immediately drop down and circle the chemical and the coefficient in the balanced chemical equation. So 18.1 grams of ammonia, it's reacted with 90.4 grams of copper 2 oxide, that's CuO. So we're going to circle that chemical and that coefficient. Here's the real question. It says, then determine the volume of nitrogen gas produced at STP. Nitrogen gas is N2. And identify the limiting and the excess reactants. Now you'll notice that this is different than a typical stoichiometry problem because we've got given quantities of two reactants. We're also asked to convert to some volume of gas at STP. For that reason, we need to convert CuO to diatomic nitrogen. We need to convert NH3 to diatomic nitrogen. And what I like to do is I like to label each one of these arrows. I'm going to label this one number 1, and I'm going to label this one number 2. Okay, I'm leaving places right down here for you to do the stoichiometry. All right, number 1 is this. Number 1 represents going from ammonia over to some volume of gas at STP, diatomic nitrogen. In particular, we're starting with 18.1 grams of ammonia. So I'm going to write down 18.1 grams of ammonia, which is NH3. Now, because we're starting with mass, which is grams, and we're going to volume of some other chemical, we could call this a gram A to volume B conversion. And we go through 3 arrows, 3 fractions that we'll set up to convert to volume in liters of diatomic nitrogen gas. In mathematical calculation number 2, we're going from 90.4 grams of CuO, copper 2 oxide. And we've got to convert to the same thing. We've shown that right here with these arrows. We've got to convert to the same thing so that we can make an apples-to-apples comparison. And so this is also a gram A to volume B conversion. Now again, in the notes, I emphasize that you might want to do this as well, right? Compare. Remember, you don't know what actual quantity is produced until you do both strings of calculations. Once you do both strings of calculations, remember you're always looking for the smaller quantity, and then you would trace it backwards and it would tell you what the limiting reaction is. All right, thank you guys. Have a great day.